Complexity, in special when implemented to achieve a specific purpose, has always only been observed to be the product of a mind. The more complex, the more evidence of design. In intelligent design arguments, complexity is more defined when we talk about specified and irreducible complexity. We see it in every living cell, combined. DNA hosts specified complexity, or in words that can be better comprehended, namely instructional assembly information. Every protein, which is the product of the information stored in DNA, is irreducibly complex. In order to perform its basic function, it must have a minimal size. Unless it has it, no deal, no function. On top of that, proteins are synthesized by the ribosome, depending on the specified complexity of the information stored in DNA. So on top of irreducible complexity, there is an interdependence of specified and irreducible complexity combined. Specified complexity of information stored in DNA dictates and directs the making of irreducible complex proteins, which all are made to perform a specific function in the cell. On top of that irreducible complexity, there are higher and higher layers of specified and irreducible complexity. Signaling is essential in every cell, even in single cells and protists, and was necessary for the first life form to emerge, no matter what it was. Signals are carriers of information that are also specified and complex. There has to be always a variegated number of signaling networks in operation, or no life. And there has to be a minimal number of proteins for life to exist, or no deal. So, proteins are individually irreducible complex, and the cell and its proteome are irreducibly complex because a minimal number of proteins is required for life to exist. Living cells are prime examples of irreducible and specified complexity, instantiated to perform a specific function. In order for there to be life, a minimal number of parts has to be there, fully implemented and operational. All at once. A working cell is more than the sum of its parts. A functioning cell must be entirely correct at once, in all its complexity.
We are all descended from some ancient organisms or group of organisms within which much of the machinery now found in all forms of life on Earth was already essentially fixed and, as part of that, hooked on today's so-called molecules of life. This machinery is enormously sophisticated, depending for its operation on many collaborating parts. The multiple collaboration provides an explanation for why the present system is so frozen now and has been for so long. So we are left wondering how the whole DNA, RNA, protein control system, on which evolution now so utterly depends, could itself have evolved. We can see that at the time of the common ancestor, this system must already have been fixed in its essentials, probably through a critical interdependence of subsystems. Roughly speaking, in a domain in which everything has come to depend on everything else, nothing can be easily changed, and our central biochemistry is very much like that.
Albert Laszlo Barabasi, a physicist and network science specialist, wrote in a science paper in 2004. Various types of interaction webs, or networks, including protein-protein interaction, metabolic, signaling and transcription regulatory networks, emerge from the sum of these interactions. None of these networks are independent, instead, they form a network of networks that is responsible for the behavior of the cell. The architectural features of molecular interaction networks within a cell are shared to a large degree by other complex systems, such as the Internet, computer chips, and society.
If the analogy of two phenomena be very close and striking, while, at the same time, the cause of one is very obvious, it becomes scarcely possible to refuse to admit the action of an analogous cause in the other, though not so obvious in itself.
If you want to know more, please see below in the description of this video. Thanks for watching, and please subscribe.